Hello, my name is Benjamin McCarley, and I will be presenting on Edwin Powell Hubble. He was born in Missouri in 1889, and he soon moved into Chicago. With academics and athletics on his side, he was admitted to Oxford on a Rhodes Scholarship. For those of you who don't know, a Rhodes Scholarship is a highly coveted scholarship that's still in use today for outstanding scholars and for a lot of people that make really good grades. Instead of astronomy, he made a promise to his dying father to study law, which he studied all throughout college, but he only practiced it for only half a year. He hated law, so he went back to school to earn a PhD in astronomy. He was good in sports, like track and field. And he went to college in Oxford in England, and as you can see, it's very prestigious, very beautiful and all. But even though he made the promise to his dying father, he remained diligent in his studies. He sat down every day. He got out one of his history books and started reading about law. He came to find out that he didn't like law at all. And so he just walked away from it and decided to follow his real passion within astronomy. So, in 1918, towards the end of World War I, he enlisted in the Army and worked his way up to a lieutenant colonel, but he never saw any fighting action. He accepted a job at Mount Wilson Observatory right after the war to research what today is called cosmology, or study of the universe and the cosmos. Mount Wilson had the biggest and most powerful telescope at that time, a whopping 100 inches, and he found his work rival, who was dead, but worked at Mount Wilson before him, Harlow Shapley, who had come out with his own theory before Hubble's theory, but Hubble didn't agree with Shapley's theory, and thus wanted to prove him wrong. So these are footages from World War I. As you can see, the fighting is very gruesome on both sides of the field, with heavy casualties in World War I on both sides, and it was not a pretty war at all. Here is a retrospect of 100 inches. This was the size of the biggest telescope during the 1920s and 30s. And as you can see, it's not very big at all. You can look at it and it's not very big at all. And so, after the war, he decided to sit down at the observatory, and he had a PhD in astronomy, so every day he would go out and look up into the stars. He would look up, see what he could see with the biggest telescope. But then he had an idea. He saw something and he had an idea. What if I make my own law? So, on the move, he took his telescope and decided to write his own law down. So, he started to formulate his own ideas, which, as you can see, is very complex, first off. It had a bunch of variables, numbers, weird signs, pies, everything imaginable. But that didn't incorporate what the law was. He was just writing down stuff. So he had to come up with a new equation, a brand new one never thought of. So he thought of one. And that is what today is now known as Hubble's law. V equals H subscript 0 times D. And again, that is what Hubble's law today is. That is the standard equation that you would use for Hubble's law. And what it's saying is objects observed in deep space are found to have a redshift, which is the velocity of various galaxies receding from the Earth, is approximately from the distance from the Earth. And he decided to write this all down, and write down his findings and everything, that the more distant a galaxy, the faster that it is receding from Earth, its recessive velocity. And so in 1929, he found an anomaly within space, causing him to create his own law. And it states that objects observed in deep space, or extragalactic space, which is 10 megaparsecs or more, which a megaparsec is 1 million parsecs, or 3.3 light years. So about a megaparsec is 3.3 million light years. And these are found to have a redshift, which is interpreted as a relative velocity away from Earth. And that this velocity of various galaxies receding from the Earth is approximately proportional to their distance from the Earth for galaxies up to a few hundred megaparsecs away. and that is many million light years, up to 33 million light years, which is about a third of the distance to the sun. So, a breakdown of Hubble's law. V equals h subscript 0 times z. D. V is your recession velocity in kilometers a second. So, that is what you are trying to solve. D is your distance in megaparsecs. That's interpreted also as light years. And h subscript 0 is the expansion rate today, which you would use something called the Hubble parameter, which you would look up in a telescope, and you could find that area. And you'd plug in the equation, for instance, let's say the expansion rate today is 1.8 times 10 to the negative ninth. You'd plug that in, you'd find the distance it is from the thing you're looking at to where you are in relative velocity, and you would find your recessive velocity. And so the more distant a galaxy is from where you're standing and looking up, the faster its recession velocity is going to be, because of that expansion rate always being proportional to the velocity. So yes, he fought in World War II and World War I. He was such a war hero. But he didn't fight in World War II. He didn't fight in World War I either. But besides the point, he fought in World War II as a ballistic scientist working and testing bombs. And yes, that included the world-famous atomic bomb. And he won a Civilian Medal of Honor for his research and development for the armed forces. Then returning to Hale Observatory in California, he worked on the new, largest telescope, being 200 inches and far more powerful than the old 100-inch telescope, and he was even the first person to try it out. And if you go to Hale Observatory today near Pasadena, California, it still exists and is erect today. It's not the most powerful telescope in the world today, though it was the most powerful telescope up until 1993, before the building of the Kaluuya telescopes and the Hubble telescope that is currently in space. So yes, these are actual World War II footage pictures of the war. As you can see, it is very gruesome, and it's more gruesome than World War I. It's very gruesome on both sides. As you can see, the American forces are suffering heavy casualties, but they eventually prevail. Hubble, as seen as the green person, joins the Army Corps of Scientists working and testing out bombs, seeing if they work, and eventually joins their ranks as a scientist to help them out. There's one thing that is disappointing about Hubble's life, is that he never won a Nobel Peace Prize, seen right here. Nobel Peace Prizes were given out to scientists that displayed exemplary work, but that didn't apply to astrophysicists, so he never got one. So anyone can look up into the night sky with any telescope and see and look at the starry sky right above them. Said anyone can look up and see the advanced starry sky above hand, and that was all because of Hubble's work and dedication into astronomy and physics. And so the Hubble telescopes in Hawaii is named after Hubble's extensive research in astronomy and physics. There's also the floating space station that currently is around Neptune, taking detailed photographs of it, and that is also because of Hubble's work. NASA has dedicated many statues and buildings to his work, and his research and his laws today still apply to modern-day physicists and help prove the relationship of the expanding universe. Physicists like Marie Curie, physicists today, use his work as a guideline and use his equation to figure out the expanding universe. And pictures such as these taken from the Hubble telescope are just perfect evidence. Here's my bibliography. Remember, this is about Hubble, and so thank you very much for watching, and take care.